Welcome to Nerdy Dives, where we take one deep technical topic and actually understand it end to end. Today, how do you prove that a RAG system actually works? You built a RAG pipeline, Retrieval Augmented Generation. In your notebook, it was flawless. Every question, a clean answer. So you shipped it. And now, in production, users are getting hallucinations. Confident, fluent, completely wrong. Here's the unsettling part. Nothing crashed, no stack trace, no error. This is the silent failure of RAG. Building the pipeline was only half the job. Knowing whether it actually works, that's the real mission. And the first rule is this: you evaluate RAG as a product, not a sum. A RAG system has two halves that multiply together, a retriever and a generator. If the retriever hands over garbage, it doesn't matter how brilliant your language model is, it's summarizing garbage. And if the generator ignores good context, it doesn't matter how perfect your retrieval was. The weakest stage caps the entire system, so "it feels better" is not a metric. You need a scoreboard. The cleanest map of that scoreboard is a 2024 survey called Auepora, a unified evaluation process for RAG. It reduces every evaluation to three questions. What are you evaluating? The target. What do you evaluate it on? The dataset. And how do you measure it? The metric. Hold on to that shape. Everything in this video is one of those three questions, asked about one of those two components. So let's start with the mental model that ties the entire field together. The RAG Triad. Three checks, arranged like a triangle over your pipeline. 1. Context relevance. Is the retrieved context actually relevant to the question? That scores the retriever. 2. Groundedness, also called faithfulness. Is the generated answer actually supported by that context, or did the model invent something? That scores the link from context to answer. 3. Answer relevance. Does the final answer actually address what the user asked? That scores the link from question to answer. Retriever. Grounding. Relevance. If all three pass, you've closed the loop. The answer is relevant, and it's backed by context that was itself relevant. And here's why practitioners love the triad. It's referenceless. You do not need a golden, human-written ground truth answer to run any of these three. Which means you can run them on live production traffic, on every request, with no labeled test set at all. Now let's open up those two components, because evaluation is really about pinpointing which one is failing. The retriever has one job: index your knowledge base, and when a query arrives, search it for the most relevant chunks. That's your embedding model, your vector store, and often a re-ranker sitting on top. The generator then takes those chunks, plus the user's query, and writes the final response. When an answer comes back bad, evaluation tells you where it broke. Is your embedding model failing to capture the nuance of the domain? Is your re-ranker ordering results poorly, burying the one good chunk down at position 9? Or is the language model simply ignoring the context you worked so hard to retrieve? Without metrics, all three failures look identical from the outside. A bad answer. With metrics, each one lights up a different part of the board. Let's go deep on the retriever first, because retrieval evaluation is about one promise. Are you feeding clean data to your generator? There are two flavors of retrieval metric. Reference-free ones, which only look at the query and the chunks you pulled, and reference-based ones, which compare what you retrieved against a known ground truth answer. Deep Eval organizes the core three as Contextual Relevancy, Contextual Recall, and Contextual Precision. They sound almost the same. They measure completely different failures. Contextual Relevancy. This measures the proportion of your retrieved chunks that are actually relevant to the input. Pull 10 chunks, and if only 3 are on topic, that's a relevancy of 30%, 7 chunks of pure noise padding your prompt. This is a direct test of two knobs: your top K, how many chunks you retrieve, and your chunk size. Crank top K too high, and you drown the answer in irrelevant text. Make chunk size too large, and every chunk carries dead weight. Make it too small, and you slice a single fact clean in half. Contextual relevancy is the metric that tells you whether those settings are tuned before that noise ever reaches the generator and quietly degrades the answer. Contextual recall. This one is reference-based. It needs a ground truth answer to compare against. The question it asks is, does the retrieved context contain all the facts that appear in the ideal answer? Say the correct answer depends on 5 specific facts, and your retrieved chunks only cover 3 of them. Your recall is 60%, and no generator on Earth can produce the complete answer because 2 of those facts were never retrieved in the first place. This is your early warning system for the embedding model. Low recall usually means your embeddings aren't domain-aware enough. They can't tell that a query about myocardial infarction should pull the chunk that says heart attack. Recall answers the bluntest question in the whole stack. Did we even fetch everything the answer needs? Contextual precision. This is the most misunderstood metric in the stack, because it is not about whether the right chunks are present. It's about whether they're ranked at the top. Precision rewards you for putting the most relevant documents first, and penalizes you for burying them under less relevant ones. But why should ordering matter if the chunk is somewhere in the prompt at all? Because of a real, measured failure mode called lost in the middle. Language models pay the most attention to the beginning and the end of a long prompt, and they systematically neglect whatever is stuck in the middle. So a perfect chunk sitting at position 8 of 10 might as well not be there. The model glides straight past it. Contextual precision is really a scorecard for your re-ranker. It's the metric that catches a retriever that finds exactly the right evidence and then presents it in exactly the wrong order. If you come from an information retrieval background, you'll want the classic ranking metrics too, the ones that score the ordered list directly. 3 worth knowing. MRR, mean reciprocal rank. It asks a single question. How far down the list is the first relevant document? If the first hit is at position 1, your reciprocal rank is 1. Position 2, a half. Position 5, 1/5. Average that across all your queries and you get MRR. Brutal, simple, and perfect when you only care about the top result. MAP, mean average precision. This averages precision across every relevant document and every query, so it rewards getting many relevant results high, not just one. And NDCG, normalized discounted cumulative gain, the gold standard for graded relevance. It applies a logarithmic discount, so a relevant document ranked low is worth less than the same document ranked high, then normalizes against the perfect possible ordering. MRR for the first hit, MAP for the whole set, NDCG when relevance comes in degrees. So suppose your retrieval is now excellent, clean, complete, well-ordered context. You are still only halfway there, because the generator has its own 2 ways to fail. It can hallucinate, assert things the context never said, or it can misread the prompt and answer a subtly different question than the one that was actually asked. 2 failure modes, 2 metrics. First, faithfulness. The same thing the triad calls groundedness. Faithfulness measures whether the answer is derived solely from the retrieved context, not from the model's training data, not from its imagination, from the context you actually gave it. And here's how it's computed. It's genuinely clever. You take the generated answer and decompose it into individual claims, atomic factual statements. Then, for each claim, you ask one question. Is this supported by the retrieved context? Count the supported claims, divide by the total. So if the answer makes 8 claims and only 6 trace back to the source, your faithfulness is 75%. And those 2 unsupported claims are, by definition, hallucinations. That's the whole trick. You put a number on, is my model making things up? Claim by claim, instead of just eyeballing the paragraph and hoping. Second, answer relevancy. This asks whether the response actually addresses the user's question. And notice, it's completely separate from whether the answer is true. You can have a perfectly faithful, perfectly grounded answer that is still totally useless. A customer asks about the technical specs of a laptop, and the model returns an accurate, beautifully sourced paragraph about the return policy. Every word true, every word irrelevant. Answer relevancy is the metric that catches that. The common way to compute it: take the generated answer and use an LLM to reverse engineer which questions it would actually answer. Then measure how close those are to the question that was really asked. So, faithfulness checks the answer against the context. Answer relevancy checks the answer against the question. And now the triad clicks into place. Context relevance scores the retriever. Faithfulness scores the answer against the context. Answer relevancy scores the answer against the question. Three numbers that together tell you not just that something is wrong, but where. And every one of them is referenceless. No golden answer required. Which is exactly why the triad is the tool of choice for monitoring production traffic in real time. Your reference-based metrics, recall and precision, those are for the lab. Development, regression testing, offline benchmarks where you have labeled data. The triad rides along in production, watching every single live request. Which raises the obvious problem. All of these metrics need test data, questions, and often ideal answers. So where does that come from? You are not going to handwrite 1,000 test cases. The modern answer is to use LLMs to evaluate LLMs, and it starts by using one to build the test set. You point a generator model at your own documents, and you ask it to write questions those documents can answer. But raw generated questions are noisy. Some are trivial. Some are unanswerable. Some only make sense if you're staring right at the source paragraph. So you add critique agents, a second pass of LLM judges that filter the batch. One checks groundedness. Can this question genuinely be answered from the document, or did the generator hallucinate a question? Another checks standalone quality. Does the question make sense on its own, without seeing the original passage? Only the questions that survive both filters make it into your evaluation set. That's exactly how the Hugging Face Cookbook builds a synthetic benchmark you can actually trust. But lean on this, and a warning light should come on. Your judge is itself a language model, with all the same biases. LLM judges show position bias. They tend to favor whichever answer they see first. Verbosity bias. They reward longer answers, regardless of quality. And self-preference. They rate text from their own model family more highly. So you do not take the judge's score as gospel. You calibrate it, spot-check a sample against human labels, confirm the judge actually agrees with people, and only then trust it to scale. The judge buys you throughput. It does not buy you ground truth, which is exactly why the serious guides, Google Clouds among them, insist on keeping humans in the loop. So far, we've assumed one question, one answer. Real systems are messier. If your RAG system is a chatbot, you hit a problem called context drift. As the conversation moves away from the opening question, retrieval that was dead on for turn 1 gets less and less relevant by turn 6. And a single overall score hides that decay completely. So you switch to turn-based metrics, something like turn faithfulness, that evaluate the system at every step of the dialogue, not just at the end. And then there's agentic RAG, where the model decides for itself when to retrieve, whether to call the search tool at all. Now you're evaluating a decision, not just an answer. And the metric there is argument correctness. When the agent did reach for the retrieval tool, did it call it with the right query? The right parameters? A RAG agent that retrieves the right way at the wrong time fails in a way no single-turn metric will ever catch.
Here's the mindset shift that separates a demo from a product.
Evaluation is not a one-time event. It's infrastructure. 3 practices make it real. First, wire it into CI/CD. Turn your metrics into a test suite. Deep eval runs right on top of PyTest, so you run it on every pull request. And a change that quietly tanks faithfulness fails the build before it ever reaches production. No regression slips through. Second, monitor cost. At production scale, redundant LLM calls, both in the pipeline and in the evaluation itself, quietly bleed money. So you track your semantic cache hit rate, as Redis recommends, so that repeated queries don't get re-embedded and re-answered from scratch. Third, trace everything. Platforms like BrainTrust capture the full pipeline, the query, the retrieved chunks, the final answer, on every request. So when a metric drops, you can do real root cause analysis, instead of guessing which stage broke. And still, you keep a human in the loop. Automated metrics are how you scale to thousands of test cases. But there are things a number will never catch. Tone, clarity, whether an answer is technically correct, but subtly unhelpful. Human reviewers judge the nuance the scorers miss. Put it all together, and the entire discipline comes down to one shift. RAG evaluation moves you from vibe-based engineering to data-driven optimization. So stop asking whether it feels better. Start capturing traces of every request. Define your scorers, and the triad is a perfect place to start. Wire them into CI, and stop guessing whether your AI actually works, because now you can measure it. That was RAG evaluation, from a single metric all the way to production. If it made the stack a little clearer, subscribe for more deep dives, and drop a comment. I read them.